Hello everyone, welcome to Home Institute. This is your Sushma ma'am. We are with the chapter Electricity, Class 10 Physics. In my previous video, we discussed about resistivity and problems on resistivity and everything. There we discussed about how the resistors are important in your day-to-day life and all, and we solved some numericals and everything. Today we'll move on to a most important concept of resistors, how the resistors are got connected in a system and all. What we discussed in the previous class, guys, the resistors are the one who are having an appreciable amount of resistance, and where it distributes a whatever the current which is passing in a circuit, it gives little bit of disturbance and all, so that the current can easily go through in a circuit and everything. So whatever the harms which causes while passing on current and everything, the resistors will overcome all those things and everything. Now I'll tell you one more thing which is very important. Resistors of a system has connected. Resistors are of two types. Resistors are giving and passing and current, how the current is passing in a circuit. There are two ways, guys. One is series, another one is parallel. One is series and another one is parallel. So today's session is about to discuss series and parallel connection, how the series connection is there, how the parallel connection is there and everything. Before moving into this one, I'll tell you one thing. I told you already in my first video only that in every home we are having 220 volt of current and everything. It is gonna distribute it to every equipments. All the equipments of electrical equipments sharing that current, that voltage is gonna share to all the equipments. How they are sharing, how they are connected in a home, whether they are connected in a series, whether they are connected in a parallel, will come to know in this video. Now just what I told you, that is resistors can be combined in two ways. One is series connection and another one is parallel connection. Let me explain you about series connection. In series connection, all the resistance got connected in a single line. They are connected in a series wise. They connected one to another. So R1, R2 and R3 are the resistance got connected in a single line, where current is passing. This is the direction of a current, guys. The current is moving through all the resistance. How the current is moving and how it is going to distribute it, we'll discuss later when we discussed separately about series connection. And the A and B are the potential difference. That is how much pressure is required for passing an current in while passing in through this R1, R2 and R3. How much voltage is there and how much pressure is gonna distributed, and whether the voltage is distributed or whether the current is gonna distributed, everything will discussed in a series connection. Just note down this one. R1, R2, R3 are the three resistance which are got connected in a single line, that is series connection. And A and B are the points where you can measure the voltage, how much pressure, potential difference, how much is there, that is gonna calculated with the help of these 2 points. Okay, now this is our parallel connection. Here R1, R2 and R3 got connected in a parallel wise. This is correct direction of a current, and the current is moving throughout the circuit like this. So in parallel connection, R1, R2, R3 got connected on like a parallel wise. That is R1 is like this, R2 is like this and R3 is like this. And there are 2 points are there here. That is those 2 points are very, very important for the connection of what, guys? That is a connection of your voltage is gonna measured with the help of again these 2 points. This A and B are the 2 points where our voltage is gonna measure the potential difference, how much is gonna distributed, everything we'll discuss later. Okay, just note down this connections. This is also very important for examination point of view. They may definitely ask you write down the series connection circuit and parallel connection circuit. Okay, how this current is distributed, how the current is passing, how to calculate the potential difference in series connection. Let me write down one thing. The resistance are connected in a series wise. Here, if 6 volt of battery is there, then it is going to distribute it to every resistance. Okay, I told you in series connection, this is very important point. In series connection, voltage is going to distributed, guys. That is potential difference is distributed to each resistance. Okay, but current, what about the current, guys? Current is same. It is equally shared to all the resistance. It means I is equal to I1, I1 is equal to I2, and about I3. This is a current passing to resistance R1, and this is the current passing to resistance R2, and I3 is the current passing in the resistance R3. But potential difference varies in series connection. This is very important. Why? Because they are connected in a series wise, and if R1 is having more resistance, it means if it has a more disturbance, then the voltage, the potential difference will be more. For example, I'll take it as a 3 ohm, and this is 2 ohm, and this is 1 ohm. So R1 is 3 ohm, R2 is 2 ohm, and R3 is 1 ohm. It is how much? Okay, let's take 3 volt, 2 volt, and 3 volt, 1 volt. So just calculate this one. Voltage is 3 plus 2 plus 1. How much, guys? 6. That 6 volt of this potential difference gonna distribute it to each resistance. That means V is equal to V1 plus V2 plus V3. How much it is? V1 is how much? 3 plus 2 plus 1. Again, it is 6 volts. How much battery is there? 6 volt. Here, potential difference is not same, guys, but current is same. Potential difference according to the resistance, according to the disturbance, it is going to distribute it to each resistance. Okay, this is the thing, this is the point where you have to remember, in series connection, current will be same. Whatever the current which is passing in a circuit is same, but potential difference varies in a circuit. Oh, okay, what I told you, in series connection, that is R1, R2, R3 resistance got connected in a single line, and current which is flowing in a circuit is always constant. Same current is moving into all the resistance, and it is whatever the current which is there in a circuit, it is going to distribute it equally. It means constant, same current is distributing. But what about potential difference, guys? That potential difference will get vary. That what I told you just now. That is, if the 6 volt battery is there, that is, if the resistance is higher in a R1, that is what a potential difference, the pressure will be high, and same thing is going to distributed in R2 and R3. But how to calculate resistance, guys? Okay, let me tell you. I is equal to what? I1, I2 and I3 all are same. So I is nothing but I1, I1 is nothing but I2, I2 is nothing but I3. But what about potential difference? V1 plus V2 plus V3. We need to add all the potential difference and all. And we know what is V according to Ohm's law. V is equal to I into R. Correct? Take this as a equation 1. Now, for V1, I will be same. So I can take it as a I only directly. R1. V2 is I R2. And V3 is I R3. Substitute 2, 3 and 4 in 1. Substitute this 2, 3, 4 in 1. What is this one? V is what, guys? IR, that I can take it as IRS, because RS means series connected resistance, series connection. Okay, IRS is equal to IR1 plus IR2 plus IR3. So IRS is equal to, take I common, R1, R2 and R3. Okay, cancel this one, and RS is equal to R1 plus R2 plus R3. This is very important. Okay, in series connections, how to calculate total resistance? How to calculate total resistance, guys? By using one formula, RS is equal to R1 plus R2 plus R3. Okay, and what about the potential difference? That is voltage. V is total voltage, is just add those distributed voltage V1, V2 and V3. V1 plus V2 plus V3. We'll solve some numericals on this topic, and you will come to know how resistance, voltage and current is gonna calculated using series connection. Okay, we'll solve some numericals. This is your first problem in series connection. An electric lamp where resistance is 20 ohm and a conductor of resistance 4 ohm are connected in series to a battery of how much volt, guys? 6 volt. Calculate current through circuit. How much current is passing through the circuit, and we need to calculate the potential difference across electric lamp and conductor. How to draw the circuit, guys? Here one conductor is there and there is one lamp is also got connected. So they are connected in series, guys. Here how much is there? This is of for resistance for electric lamp is 20 ohm and this is of 4 ohm. So this will be our resistance. How the resistance is calculated in the given circuit? I already told you, resistance can be calculated by using what, guys? R1 plus R2, correct? They got connected as series. So what they had given, R1 is how much, guys? 4 ohm. Okay, and R2 is how much? 20 ohm. Okay, what about R? Electric lamp. Okay, what about R, guys? R1 plus R2, correct? So how much? 4 plus 20. So resistance is how much? 24 ohm. So don't forget to write down the unit, guys. This is very important. Now we need to calculate V is equal to what, guys? I into R. We don't know how much current is passing in a circuit. I is equal to what? V divided by R. What is R now? And what is V? What they had given? V is how much? It is 6 volt. It is of 6 volt. V divided by RS means V is how much? 6 divided by 24. 6 ones are 6 fours are. It is about 0.25 ampere. This I is how much? 0.25 ampere. This is the first whatever they are asking, we solve that one, that how much current is passing through the circuit. This is about 0.25 ampere. And one thing, please note down, you may get some application questions in a series connection, that is how much push is there in a series connection. More the push, more the resistance. More the resistance, if the connector contains more resistance, more disturbance, definitely the pressure will be high for passing in current and everything. For that, you please note down that point also. More the resistance, more the current. Okay, if more the current means more, if resistance is much in the given circuit, 100% there will be a pressure will be high. The potential difference will be high. Please note down this one. Okay. Now, what we need to calculate in a second part, PD, potential difference for R1. Correct? V is equal to what, guys? IR. Correct? So IR1. I is how much? 0.25. And R1 is how much? 4. How much you will get? Tell me. How much you got? V is equal to how much? 1 volt. So this is V1. Okay. What about V2? Again, this is V1. IR2. I is constant. 0.25 into R2 is how much? 20. Which is approximately equal to 5 watt. Okay. This finishes your first numerical in series connection. Okay, let's move on to the next problem. What they had given, what is the maximum resistance which can be made by using 5 resistors, each of 1/5 ohm. You have to draw the circuit for this, then it is very easy to solve such a kind of problems. Okay. First, let me draw. How many resistors are there, guys? Resistors are there. Total 5. 1, 2, 3, 4, and the 5. They got connected to an battery. Each of are having a resistance 1/5 ohm. Correct? What is the meaning of maximum resistance means? What is that? Nothing but total resistance. It is nothing but total resistance we need to calculate. Sorry, this one is R5. So, total resistance is equal to how much? R1, R2, R3, R4 and R5. How much, guys? 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. It is equal to 5 divided by 5. How much? 1 ohm. So, total resistance is how much you got? 1 ohm. Okay? Write down. Okay, let's move on to the next problem. What they had given, study the following circuit and find the current following through circuit and potential difference across 10 ohm. What they had given in the following circuit, they had given R1 and R2, guys. That is your resistance. And we need to calculate the current. That is, what is the direction of the current, guys? This is the direction of the current. I we need to calculate, and also we need to calculate the V. For V1 we need to calculate because we need to calculate across the resistance 10 ohm. Where is the resistance 10 ohm is present? It is in the R1. And let's move on to our formula. Okay. What they had given, guys? Given R1 is how much? 10 ohm. And R2 is how much? 20 ohms. Okay. This is 20 ohm. And what is V, guys? 3 volt. Now, total resistance in series is R1 plus R2. How much it is? 10 plus 20. That is equal to 30 ohm. So, R is how much? 30 ohm. Now, let's calculate the first part. That is I. Don't know I. What is I? What is the formula for Ohm's law? V is equal to IR. Correct? For I is equal to V divided by R. What is V, guys? 3 divided by 30. 3 ones are 3 tens are 1 divided by 10. That is equal to 0.1. ampere. So first one got finished, correct? Now we move on to a second part. So we need to calculate V1 for a resistance 10 ohm. Okay. So what is the formula? V is equal to I into R. How much we got I? 0.1 into, for R1 it is, for R1 that is 10. So how much we got? 0.1 into 10, that is nothing but 1 volt. Okay. If they had given circuit, and from that circuit we need to identify whatever the given part is there in the given information. Okay, please write down. Okay, we finished how the resistance is connected in a series and all. Now resistance in parallel we'll see. Okay, that what I discussed in the previous session, that is resistance are connected in a parallel wise on another. Both the ends of those resistance got connected with a voltage. What is the difference between series connection and the parallel connection, guys? There, what is constant? I will be constant in a series connection, but here, this is very important note on, I will be changing. I will not remains constant, but potential difference, V remains constant in parallel. What is the first note, guys? So V remains constant. V remains constant. But what is the second note? Very important. I is different for different resistance. If more the resistance, the passing of a current will be less. If less the resistance, the current will flow easily and there is a more current because R is inversely proportional to what, guys? Your current, and current and R are inversely proportional to each other. I increases, R decreases. When R increases, definitely I decreases. Come back. Now I1, I2, I3 are the different currents that is gonna sharing with a different resistors. So what is the second point? I is different. I is different. From the note 1, what we can say? So V is equal to V1, which is equal to V2 and which is equal to V3. And what about I, guys? I is equal to I1 plus I2 plus I3. This is, take it as equation 1. I'll derive how to calculate the total resistance. Okay, I'll show you. So what is our equation for our Ohm's law? According to Ohm's law, what we can write? V is equal to what, guys? I into R. So I is equal to what? V divided by R. Okay. For resistance R1, I1 is equal to how much, guys? V divided by R1. I can take V, no need to take V1, V2, V3 because V is constant. And for R2, V divided by R2, for I2 it is. For I2, V divided by R2. And for I3, V divided by R3. Now substitute this 2, 3 and 4 in equation 1. Now I'll put this 2, 3, 4 in what, guys? In 1. What I will get? I that will becomes, let's take it as I only. I is equal to what we got for I1? V divided by R1 plus V divided by R2 plus V divided by R3. I can take I as V divided by RP because it is a parallel connection. Okay, that is equal to V by R1 plus V by R2 plus V by R3. We will get cancelled. So resistance is equal to 1 by R1, 1 by R2 plus 1 by R3. This is very important. So reciprocal of a resistance gives a total resistance in a parallel connection. Okay, please note down this. This is the formula to calculate the resistance. How to calculate a resistance? Total resistance in a parallel connection, 1 divided by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on. How many resistance are there? That much resistance you need to take it as a reciprocal way. Okay, please note down this one. Let's move on to the numerical part of a parallel connection, guys. What they had given. The resistors R1, R2 and R3. R1, R2 and R3 are connected in a parallel with a resistance. How much resistance is there for each resistor? 5 ohm, 10 ohm and 30 ohm respectively. And they connected to how much battery, how much voltage is there, guys? 12 volt battery. And we need to calculate the current. Individual current is how much is passing for R1, how much is passing for R2 and how much for R3, and total current. We need to add all those currents, and lastly we need to calculate the total resistance. Okay, 5, 10, 30 is the total resistance. We need to calculate in a third part. What they had given, how much potential difference is there? 12 volt. It is same for all the resistance, guys. This is very important. Here also it is 12 volt, here also it is 12 volt and here also it is 12 volts. Okay, let's move on to our first part. Current through each resistors. So I is equal to V is equal to I by V is equal to what, guys? IR. I is equal to what? V divided by R1. What is our V? 12 divided by what is our R1? 5. How much you will get? Tell me. How much you will get? 5 1s are 5 2s are 2.4 ampere. Okay, this is I1. And what about I2, guys? V divided by R2. How much we are having for V? 12 divided by 10. 2 6 are 2 5s are. How much we will get? 5 1s are 5. 1.2 ampere. Now for I3 is how much? V divided by R3. That is V is how much? 12 again. And what about this one? 30. So how much we will get? 2 6 are 2 15s are. So around how much we will get, guys? Tell me. 0.4 ampere. Okay, this is our first part. And what about in a second part, guys? We need to add all those total current I1, I2 and the I3. How much you will get? 2.4 plus 1.2 plus 0.4. Calculate. It is approximately 4 ampere. Okay. What is our third part? What they are asking us? That is total resistance. What is the formula for a total resistance in a parallel connection? Yes. This 1 divided by Rp is equal to 1 by R1, 1 by R2 plus 1 by R3. What is our R1? 1 by 5 plus 1 by 10 plus 1 by 30. How much we will get? Take LCM for 5, 10 and 30. How much you will get? Okay, just 30. 5 6 are 30, 10 3 are 30 plus 1. 6 plus 3, 9, 9 plus 1, 10 divided by 30. How much you will get? Tell me. Don't wait for the answers. Okay. Tell me the answer. It's about 0.3 ohm. Okay. So this is what we need to calculate in this problem. What they had given the individual resistance with the same potential difference. We need to calculate for I. Different I we need to calculate for the respective resistance. And once we got the different I, then we need to add those I current so that we can get total current. And lastly, we have to calculate the resistance in a total resistance in a parallel connection by reciprocating the resistance given in a circuit. How much you got? 0.3 ampere. So numerical part got finished in a series and parallel. Now I tell you what are the advantages of parallel connection over series connection. Parallel connection, in first note down, in series connection, same current is flowing to all the resistance, correct? if you connected if you connected a heater and a lamp in a series connection, what happened, guys? Okay, let take one any bulb or any or electric heater and all. If the current is distributing equally in a series connection, what will going to be happen? The bulb requires small amount of current, where the heater requires much more amount of current. But in series connection, it will be not possible, correct? But what about in a parallel connection? Over this, you can, the individually the current will be different, where the pressure is same, there is a potential difference is same, but the current, whatever the current which is flowing in a circuit is different. So in that connection, what if lamp requires less amount of current, definitely it takes less current, and the heater needs more current, and heater will take more current in a parallel connection. This is what the parallel connection. The current is not dividing equally in a parallel connection. And also one thing you just note down, total resistance, just note down here, total resistance is very less compared to individual resistance in parallel. In parallel connection, total resistance is comparatively very small for an individual resistance, correct? What will going to be happen when less resistance, more the current, and there is a flow of current will be very easy in parallel connection. What about in series, guys? A total resistance will be high compared to individual resistance. Then what will going to be happen? The push, whatever the push needs in that circuit will be more, and the flow of current will become very slow. So parallel connection has a more advantage over series connection, because less the resistance, more the current flow, and the potential difference is gonna distributed individually, and it is not be same. It will be, current will not be same, current will be distributed according to the individual each resistance, and potential difference remains always constant. And please do watch, share, and subscribe my video. Thank you so much.